So now I would like to again invite Dr. Sachi Nandan Mohanty to present his topic. So please.
Okay. So am I audible?
Yes,
am I
sir.
audible, madam?
Yes, sir. Good morning, sir.
Yeah. So let me share. So my screen is visible, right?
Yes, sir, visible.
Yeah. So very good evening to one and to everyone to join this today talk. So my talk basically on the revolutionizing of healthcare with Gen AI, genetic AI, innovation in medical image and clinical decision making. So this basically focus on AI in oncology, artificial intelligence in oncology. So how your early detection of cancer will be diagnosis and how you will be identify the early detection. So that I do more focusing this one. And some AI also discuss the fundamental things. So these are my outline of the talk: introduction to AI in radiation therapy, then application of AI in radiation therapy, then convolutional neural network I've detailed explained with the help of some example. How the feature extraction with the huge amount of data is there, then how you extract the features. Then what are the tools are available for analysis after getting the objective defines. Then how to, after analysis, how to measure your performance of your work. Then some case study, I'll do some publication work. Then what are the current limitation as of now in India is concerned for the future of AI in radiation oncology. This is the data we have collected by Indian Council of Medical Research, ICMR. ICMR is one of the predominant in India. We can find out the survey report is saying that 3 in 5 individuals in India die after cancer diagnosis. The women disappointingly affected studies. So what is meaning here? This study recently in 2025 in February, you can find out here 2025 February and a few months before only. So this you can find out how to identify a particular when called the ICMR study. Then after a few days, we can find the South and East Asia cancer death rise 85% by 2050. WHO World Health Organization identify in February 4th, 2025. We identify in a Southeast Asia, the death rise will be increases 85% in 2050. And this South Asia regions includes nothing but your India, Bangladesh, Bhutan, then we can go Republic Korea, Indonesia, Maldives, Myanmar, and the Nepal. So these are the very, we can call the number of patients day by day increasing. And we identify the different type of hospital they contact, the different government and private. They did one study. Then they expected this was about 2050. So 85% of death will be by the cancer, the cause of the death. Now, business standard in November 29 in 2024. So he identified, so the breast cancer causes the seen among the young Indian women over the last 3 decades. So this also supported by the ICMR. Indian Council of Medical Research Agency says that the cancer killing nearly 2,200 people per day in India, specifically UP, Maharashtra is the biggest contributor. That means most part is UP and Maharashtra. So people are die in case of cancer. You know, different type of cancer is there. So these are the not only particular one cancer, different type of cancer. We'll discuss in details with the statistics report. Now you see, in a National Cancer Registry Program Report 2020, he identified by ICMR again 13.9 lakh case cancer in India 2020. In the number like to be rise 15.7. Now you see how exponentially it will grow the cancer death per day. We can find the different type of here you can see the different type of cancer patients, include all cancer patients, and this is the x-axis in the year. Now you see the male and female, the ratio gender you can call. So this brown color called the female and the green color is the total and the blue color is the male. Now you can identify here, the statistics says that year-wise total cancer in ICMAT 2016 to 2019, the 3-year study, we can find the number of female is more than the number of males. So number of female dies in more in cancer as compared to the female. And the estimated mortality of cancer in case of India is concerned. So as per the India is concerned, you can more cancer will be the China and sometime also Japan also. Now this is the brief statistics. We can call a different type of cancer statistics in 2020 report. And from a National Cancer Registry Program India, so you see the proportion is percentage, and this is the breast cancer from the female, and you call the cervical cancer, then head and neck cancer, and the lung cancer. So they are the different type of cancer, and majorly the breast cancer, lung cancer, head and neck cancer is the most predominant the other cancers. So why this happening this is? So this is the most cases we can call the proportion gradually increases in case of female as compared to the male. Now the research in AI, we can found that AI not only for the cancer treatment, but also it is useful for the treatment planning. For treatment planning, AI also use, we can call the patient care management also AI use. Like our image segmentation, whether the tumor image and non-tumor image, malignant or benign, that also use. And detection of classification I use. And most research AI are with image segmentation. Now see, 254, we count the number of research in AI will be more in a image segmentation rather than the others. After the image segmentation, we'll call the outcome predictions, then come the synthetic image generation. And the last one you can do the pattern patient positioning is a less MI you can use. And if you divide the two parts, so we can call the deep learning, you can is one of the major component now in a research era. And deep components we can deep learning basically used for the detection and classification as well as the image segmentation. Now, in right hand side you can see these are the most cancer. You can call the bone cancer, pelvic cancer, abdomen cancer, thorax, HN stands for head and neck cancer, and brain cancer. So these are the different types of cancer. Majorly is Indian in constant. Estimate the burden of cancer, the global cancer obesity says that. So these are the mortality of male. So it will be more in case of estimated number of in a millions. So like the incident male and incident female, the female mortality will be less and male mortality will be little bit high. This is called nothing but the 2022 to and 2050, the estimated male and female over the age starting from 0 to 85 years. Now coming to the artificial intelligence, how artificial intelligence is transforming the knowledge from radiation therapy. So radiation therapy is one of the common treatment procedure when you identify a particular brain, any type of cancer. So radiation therapy, one is there, one is called the chemotherapy, then one is called the surgery. And recently new techniques arrived that is called immunotherapy. So I'll tell you what is the difference between chemotherapy and immunotherapy. Chemotherapy, what we'll do, we'll take the chemo, suppose one person, different type of cycles are there. So what happened, the chemotherapy will kill the tissues, both the cancerous tissue and non-cancerous tissues. But the immunotherapy, what we'll do, we can call the surgically, we can find out, we can only target it. Those are, we can call target therapy. This is also called the target therapy. So those are particularly cancer tissues, that tissue will be the destroyed, and immunity power of the increasing, those are non-cancer tissues. So but recently the one company Sun Pharma having the patent of that immunotherapy, but immunotherapy is too much costly as compared to the other therapy. So the patent planning by using Mirada Medical in 2008, one company they have established automated contouring software So that will be identified by dose optimizations. So how much dose, suppose you are in stage 1, stage 2, stage 3, stage 4. So that will be dose optimized. Then image analysis, the software like a subtitle medicals also there. Then adaptive radiotherapy, lung cancer treatment, that also movement during the bathing. The treatment delivery also, motion management, real-time management, your pronoun software is also there. We can find the treatment delivery. Then predictive analysis, outcome prediction, IBM version, we really develop a product we can call the breast cancer patient. Only particular for the breast cancer patient, the IBM version develop a particular product, we can find the predictive analysis. So you can given the all the symptoms of the particular patient, the IBM version, that machines will be the software will be developed outcome prediction. In workflow efficiency also there, we can call the documentation process, radiation oncology, and can reduce the error. And finally, the research and development, we can call a personalized medicines. We can AI can personalize treatment plan based on the genetic, environmental, and lifestyle factor that also useful for the AI. For the challenge and considerations. So first thing is the data privacy. The data privacy is a major challenge nowadays. When you entering the place, the data should be hide and the security is crucial. The AI system required large database to function effectively. Then integration. So integration means you can integrate in the AI in different type of healthcare systems. The workflow requires a careful planning or training or adaptations. The regulation is the regulatory framework must be involved the key pieces of the rapid advancement, or you can call the AI technology, ensure we can find the patient should be safety and efficacy of AI driven treatment. So what are the treatments you are given on the basis of AI? How the regulatory framework you have to develop? There should be a regulatory framework, and for the particular patients that you have to challenging and consideration nowadays. Now, as I already told you, data is most important. So what exactly AI will do? So AI nothing but the data. Suppose you asked AI to generate a person who can write left hand side. So AI will generate a person who writing in the right hand side. Why? Because the major population in India, you can call the around 85% population, they are habituated write in right hand side. So that means the AI is nothing but the data driven. So what are the data are there on the basis of training and testing? So we can find the data. The majority class is the unbalanced class. So majority class is the writing concept. So that's why the image should be the right hand side. But here also same thing. When you analyze a particular analysis, so by any type of method you can adapt it, no problem. But the moment you use the AI tools, so you have to find out what exactly the data speak. The most important integration is the data. So data in a electronic health record, EHR means electronic health record, whatever the data you have received from the patient, you have to manually enter in a computer system. And the patient will be fill a particular performa, you can find it manually, can fill. Now in a Tata Memorial also, they can use a record on the basis of manual enter the data in a computer system. So when you input the idea and the data to this particular, suppose a black box within the machine will find out some output, right? So in the output, what will do, this is nothing but your interpretation. So how you interpret from the output on the basis of your domain knowledge, right? Suppose you can find out, suppose the blood, the body temperatures. So body temperature, your fever is not a disease. Fever is a symptoms, right? On the basis of fever symptoms, we can identify which type of disease you have, right? So which type of fever you have. That you can identify on the technical analysis. So electronic health record is one of the most data, we can call the data. You can put a garbage will be output. So when you identify a particular how to get the data, the collection of data is nothing but every action, each patient should be digitized and entered to the system. And each digitized should be action is stored systematically. If stored is retrieval, then retrieval should be analyzable. So these are the all are called the sequence process. So first you have to collect the data, store in a memory, then you access the data in systematically, then after that what happen, you can analyze. So these are the some systematic you can go for the data records, right? Now in a electronic health records, how the data is there, you have to read the data in a nowadays computer systems are there, you can put in Excel format, data should be entered and the data should be uploaded in Excel format, then we can get the correlated of the data, they can find the what should be the output from the Excel. Now data driven research strategy, what will do, there is a two type of research we can do. One is called the hypothesis driven or the data driven. Hypothesis driven, what happen, you can find the hypothesis, then collect the data, then you have to prove the null hypothesis or alternate hypothesis is satisfy your constant or not, then you can put the collect the data, then the analysis, then interpret the data. Then you have to find the new biomarker, which is nothing but the validation, where the clinical validation you have to check whether the data is clinically validated or not. Another is called the data driven. As I already told you, in data driven what happened? So hypothesis will not generate fast. First you collect the data, then the data should be validated, then analysis, then interpret, then you design the hypothesis. Then after that, a new biomarker and the validation will be done. So these are the two different approach we can find in a medical clinical decision. Now, in a data-driven, what happens? So whether the REPUL, we can find out the trial result is applicable to a particular data set or not. Suppose we can find a 30 images, and 10 images we can found. Then you supply it to the particular set of data. Then you can find whether it is a cancer or not, right? The immunotherapy is given or not. So that type of decision will be tell. So that AI will tells different type of solution, but you have to find out which solution is appropriate for a particular patient. The particular treatment is not applicable for all the patients. So patient treatment is very, we can call the sign to sign. Sign to sign means what type of symptoms is there in an X patient. Suppose both the patients having, we can call the lungs cancer. So treatments should be different. So treatments should be the same, right? So on the basis of their symptoms, we can find the treatment. Now, the data-driven research, it is one of the recent paper in clinical oncology, the Nature, the review, they identify the patient-driven, data-driven research, we have to collect the data in efficient way so that we can find the age, can find the gender, then the date of diagnosis, the tumor histology. Tumor histology means we can find the size of the tumor, we can find the image, the color of the tumor, okay, whether the tumor is gradually increasing or not. All these things we have to find. Then socio-economic status, or the study style is there or not, then what is the family background is there. All the data should be data will be collected. Then we can find the height, weight. These are the clinical measure. We can the body surface area, and all this after getting. So outcomes should be find out the cause of the death, then the date of the death. Then you can call the diagnosis of the date, or we can find the admission in a discharge in a particular hospital. Then patient reported functional. Can expected by on the basis of patient and the treatment is concerned. Now, suppose you can find a 20 to 25 variables, so you can collect by using optimize. So the data collection must be required 4 to 6 months. Then the 2 to 3 months will be analysis. And writing we can call the 1 to 2 months. Then you can publish a report. We can find the 3 to 6 months after the peer review process. Now, the radiation oncology is one of the major role when the treatment in a particular cancer patients. So radiation oncology basically do from 1980 onwards. The clinical trials, before clinical trials, people are find out 1980. And that time also cancers are not prominently aggravated because people are not getting that much of scope or that much of facility to go and start the treatment and proceed the treatment. But nowadays, what happened? The AI techniques are so fast. People are easily consult any doctor, any hospital. They can find on the basis of treatment analysis. They can find whether there is cancer happening or not, or we can call what the stage of cancer. The generation of data, then AI models trained in the deployment. We can find the prediction, then smarter data collection and the validation, then find the incorporating the workflow. So what is the workflow here? So what's the workflow means? This is the workflow. So first the registration, then you collect the data. After collect the data, you can find the functional test. Functional test means you can the biopsy or imaging or CT images, or you can call the ultrasound or CT images. Many type of are there called the blood investigation, then a tumor marker, the next generation sequencing. So this is called the clinical visit, right? After clinical visit, what happened? We can find the post-cancer plan and previous cancer plan related to diagnosis, then find the event include the death, or it can replace the local, regional, then kind of usually event, so warrants. The different type of can find the new primaries are there. After that, what happened? Diagnosis of the patient is the multiple diagnosis, then is a create a prescription. If not multiple diagnosis, then patient have a multiple diagnosis status is there. Then patient can have multiple tumors are there or not. Synchronize and meta-synchronize should be there. Then patient who have a multiple class, then you can replace the prognosis also there. Then after prognosis, you can consider the new status. So this is a series of process. So series of process when you identify a particular radiation oncology process, you can identify and that much of how much radiation is there, how much the target is you can put, then you can go Becky therapy is one of the concept of what is the Becky therapy will give it, then how much Becky therapy will give. Okay. So that is radiation can related to toxic, then is a side effect also there in according to while the patient is a radiotherapy within the 3 months or not, the completion, how many cycle have done. So these things, so dashboard will be created particular student. Now, when you high quality data without thinking about it, the quality of data, as I already tell you, every action the patients are digitized, or every digitized should be stored systematically. Then you can call the store it a retrieval and retrieval should be analyzable. So this is the, we can call the new topic, we can call one is called the Elkata, variable Elkata, one is software who automatically store the analysis and you give the output. Now, high quality data plus idea. So idea means you have to, suppose many patients are there, you can find many patients, you can find the amplitude or lower amplitude or every amplitude, you can give in suppose some diagnosis method. Then after that, you can attempt the day 1, day 2, day 3 sequence of attempts. So patient, then a high quality treatment will tell the decision, so what type of your disease you have. Similarly, the radio mix will come. So this is the new topic or new idea we can call. The radio means control variable features and the non-control variable features. So what is control variable features? Control feature means the feature which is under your control. So that is called the controllable features. For example, your weight. So weight is in your control. Suppose today you have suppose 60 kilo, you do some exercise on something, walking or something you do, or you can dieting will do, your weight will be maybe 55 or 56 gradually down. So that is your control. But height is not your control. The height 5'6" means whatever may do exercise, whatever took medicine, anything. Height 56 means 5.6 means 556 will fix. Height is not a control features, right? So these are called in radio mix. What type of control features are there, and how the feature will be the more interpretable, that also thinking by the radio mix. It gives the large amount of quantitative features, the medical images like CT images, electromagnetic radiation, MRI images, and PET scan images. So people are not go for directly PET scan images immediately. So because PET scan image is too much costly, so first you go for CT images. If tumor is not detected, then go for MRI images. If MRI tumor is not detected, go for the PET scan images. So this is the sequence of follow we have to find out the controllable feature analysis. And radiomics will help to enhance the precision medicine, provide the non-invasive and reproducible details insight into disease process. So that will be radiomics will details. Then coming to our method, we can call the AI. How AI will be helpful to clinical decision making when oncology is concerned. Okay. So first I'll discuss the autoencoder. So in autoencoder, what happened? So in autoencoder, you see this is nothing but a additional version. You can call a advanced version of the neural network. Those who having know the neural network, this is the advanced version of the neural network. So what autoencoder tells? Autoencoder tells. So when you implement an autoencoder, first and foremost, you have to remember the number of neurons in the input layer must be equal to number of input in an output layer. This is the first and foremost you have to consider. Now you could question why? Because if your input layer and output layer is mismatched, that means you are losing some essential information while compress and decompress techniques. So whatever data set is there, all the features you input as an input, that will be compressed and pass the information between all the features, so that what happen, the feature having lower value, that also get the chances to participate with the highest value. That means sometimes what happen, the lowest feature value also take the decision on predominate to the highest value. So that's why the bottleneck layer, this is called the up to decoder, encoder, and the right hand side part is called decoder. So automatically it will be decode and the encode to compress and decompress of the particular data, mainly applied the face recognition or in the cancer disease diagnosis, the representation, and this process is called the representation learning. And many type of autoencoders are there. We call the under autoencoder and the pass autoencoder, stack autoencoder. So many autoencoders are there. We have to find out which autoencoder basically use and what type of domain in this respect to your particular data set. The different type of step autoencoders are there. One is called the autoencoder. So in autoencoder, what input layer is a raw input data, the capturing all the informations. Then the decoder, what will do, that bottleneck layer, the input, the hidden layer, that will represent the dimensionality of the original input. Then after that, what happens, the loss function you have to identify. Loss means nothing but error function. You can calculate the loss function as much as 0. Then the loss function typically the reconstruct of the losses, then measuring the difference between input and the reconstruct output. Then common choice would be the mean square error you can find, and many type of entropies are there, binary entropy or the cross-sectional entropy are there. You can find any type of loss function. During the training, so what happened, autoencoder learned to minimize the reconstruction loss, the capturing the most important features, so that the input data is lower dimensional representation are really participated across the decoder attempt and reconstruct the original input from the compressed information. So these are the graphical representation how autoencoder and decoder actually work. As you know, the loss function can define the regularizer. So regularizer means we can find how will be loss function will be smoothened and regularized in case of different type of autoencoders. As I already told you, deep autoencoder and star autoencoder. So deep autoencoder means the output of the one autoencoder would be input to the another autoencoder, and so on and so forth. Similarly, the decoding and the coding. So after decoding, output will given to the input to the autoencoder, and like that, so on and so forth. Similarly, encoding also you can do so on and so forth, right? In this way. Similarly, stack autoencoder, what happened? Just like a data structure star, everybody know in a data structure, the stack is the fast in, fast out concept. Similarly, the autoencoder also fast in first order concept. Now coming to regularization. So regularization basically prefer the size of the data set. You can find the regularization is reduce the variance of the model. If the variance of the model is too much high, then what happens? Very difficult to interpret what is the result of the data. So data points are the within the variance and among the variance too much high is very difficult to predict what type of digit it is. So that's why the regularization will reduce the variations of the model and approach the overfitting. And second thing, you can reduce the overfitting model, or you can call the underfitting. The preferred size is very small. Then go for the underfitting, or chances of preferred size is that is more. Chances of overfitting is there. So that will be controlled by the your regularization, right? Now coming to the autoencoder, so we can find how autoencoder will be compared to the principal component analysis. Any doubt as of now, or we can proceed? Any doubt from any participant? Any doubt? Okay, so look at the binary image. You see the green color are images. So these images, what will do? I'm explaining the principal component analysis with the help of one example. So this is the binary images. So you can find the binary images. The value is equal to start from 0 to 7. Here start to 0 to 7, right? So what will do? You find the pixel value of this particular images. Suppose 0, 1, 2, 3, 0, 1, 2, 3, 4. So 3, 4, I write the 3, 4. Similarly, I have to collect all the pixel values. So how many pixel values are there? 1, 2, 3, 6, 8. Now see 8 numbers are there. In this way, I collect all the pixel value position. Up to clear? Now, what is the next step? I take the summation. 3 plus 4 plus 4 plus 4 plus 5 plus 5 plus 5 plus 6 divided by 8. So 4.5. Similarly, here also for the numerator plus and denominator plus divided by 8, look at 4.5. This mu x is nothing but mean of x. Is nothing but mean of x, right? After getting mean of x, we the subtract x1 minus mu x. So 3 minus 4.5 minus 4.5. 4 minus 4.5 minus 0.5. So this is equal to x minus mu x. And we convert into x minus mu x transpose. You know the row become column, a column become row is equal to transpose. I identify minus 1.5 minus 0.5 multiply minus 1.5 0.5. So we will get this one. And this is nothing but x minus mu x multiplied by x minus mu x transpose. So this is called the x1. Similarly, x2, x3, x4, x5, x6, x7, x8, you can easily do it, right? So x2 what happened? 4 minus 4.5, 3 minus 4.5, then again multiply. So this is nothing but we can call it x2. Similarly, x3, x4. So you add all these things. x4 plus x2 plus x3 plus x4. So you got 2 by 2 row, 2 by 2 matrix. You can easily add, no problem. After that, what happened? Divide by 8. And this is called the covariance matrix. And this covariance matrix is nothing but 0.75, 0.375, 0. So after this covariance matrix is a 2 row, 2 column. This is the quadratic equation. We can find the lambda and find the solution of the lambda. I'll put the lambda, then is equal to 0. Then lambda is equal to, I can get it, right? Multiply these two is equal to this. You can get the lambda value. And this lambda is nothing but E1 is nothing but eigenvector. And after getting these eigenvectors, so what we'll do? These eigenvector just superimpose these two vectors in this image. Now you see, most of the data points towards the E1 rather than the E2. See, towards the E1 is there rather than the E2. So what is the meaning here? The meaning says that most of the data points are inclined towards the eigenvector 1 rather than the eigenvector 2. If eigenvector 1 means you can find the data will be inclined towards the eigenvector 1, and that vector is nothing but your principal component. So this is called the 1 component, so we can get it. Now you see the output. If the principal component 1, this is the original input. If using principal component 1, the output looks like. If the principal component 5, output looks like. If principal component 25, output looks this like. That means the original images are mostly equivalent to the principal component output of the images with principal component 25. So you can see mostly are very, very close. So principal component analysis is basically used for your data is linear. What about data in a curve structure? If linear one line is there, then principal component is identified. If the line will be curved, it's very, very difficult in real life situation how to classify the image input. For that, we call the autoencoder comes to picture. Autoencoder basically used for the non-linear classification. Look at another handwritten character. So someone write maybe handwritten is this one, 0. All are 0, but handwriting may be different. Similarly, all are 1, but handwriting may be different. Similarly, all are 9 here, handwriting may be different. Now, how to handwriting recognitions? They identify the training images 60,000 and 10 images 10,000 and image dimension this one. By using this by autoencoder principal component analysis, you see the output. But PCA, this is the outputs. Anybody identify what is the meaning this output? In 2-layer autoencoder, it looks like output, and 2-layer autoencoder with the sigmoid nonlinear function, this is the output. Now just compare this one. So what is the different color? Each color represent one digit. See, the maroon color represent 0. Little bit orange color represent the 1. Similarly, the blue color represent 9. So here what happened, it's very, very difficult to segregate which digit is what represent. That means overlapping are there. In this case, overlapping 0, 1, 2 are overlapping each other. When you compare this picture, you see the hair level difference, this one and this one. See, this is called the 0, and this is called the 1, and this hyena color is called the 8, and blue is called the 9. Now you can see. So here we cannot say the 100% is correct, but at least more than 90% can easily visualize what digit is what. That means the 0 is 0, 1 is 1, like that. At least 90% can classify. But in this case, what happened is unable to classify. Now look at here. By principal component analysis, the output looks like. By autoencoder, output looks like. Original is your output. That means the prominently not visible. That means the principal component output, though it's visible, but not prominently visible. But whereas in autoencoder output, it's prominently visible as compared to the principal component analysis output, right? So this thing I already discussed, the autoencoder. Now coming to the convolutional neural network. In convolutional neural network, what happened? I'm coming to the AI. So as your CNN, people are telling the CNN, everyone telling CNN. The CNN stands for convolutional neural network. In convolutional neural network, what happened? Right? Two things are there. One is called the convolution. One is called the time invariant and the shift invariant. In time invariant, what happened? At x1 at t1, y is equal to x1 plus t1. Same time, y1 is equal to y2 is equal to x2 plus t2. So y1 plus y2 is equal to x1 plus x2 into t1 plus t2. In particular time t, what x receiving the input, and what getting the Y is a predictive output the Y. So now in the CNN architecture, we have to follow one architecture that is called the pooling, nonlinearity, convolution, and images. Similarly, the same thing, we can find the n number of convolutions, then the output of the convolutions is not your solution. Remember, people are telling output of the convolution neural network is solution. No. Output of the convolution neural network is nothing but input to the fully connected neural network. And output of the fully connected neural network is nothing but your solution. Now we put a question. So what is the need of CNN? We can supply the data to artificial neural network or fully connected neural network. You can do it, no problem. But suppose you think you have 1,000 and 1,000 or million and million of features. If you supply a million and million features to fully connected neural network, you will take 10 years time to take the decision. So before you supply the data to fully connected neural network, the CNN will tell the optimal feature space. Those feature space are really participated for fully connected neural network to take the decision. So out of 1,000 features, suppose 100 features are coming from the CNN, these 100 features is nothing but output of the CNN is nothing but your optimal feature space. So these 9,900 features are not required at all. So these 100 number of features are more prominent features or optimal feature they can use by using fully connected neural network and take the decision. So this is the overall of the CNN is work, right? Similarly, in a CNN architecture, we can call the convolutional layer and the respective field non-linearity and the pooling. Color images, you can call the C, look at the colored image, 3D convolution neural network. Similarly, you can have 2D convolution neural network also there. So each convolution, you can find the kernel, the size of the kernel, and the kernel will be passes all the over the respective field and extract the information by using a stack. Now look at here, the image size is equal to 32, 32.3 and the RGB, and 10 kernel size is 5 into 5.3. Then kernel size you have to divide on the basis of your image, and always try to kernel size should be odd number. Why odd number? I'll tell you. And output of feature should be 32 to 10. Why? Because the 10 kernel size, so it should be 10. So each having one information, right? Then the nonlinearity will come to picture, and the nonlinearity will tells the threshold value, which is greater than 1, that will be considered, which is less than 1, that will be not considered, right? So in a CNN architecture, we can find out the first convolutional neural network. These are the is nothing but what you can call the boat, and some water also there, and some image also there here. I can find out by using fast convolutional network, all the images will be segregated. Then finally, you apply the fast pooling. So I'll tell you what is pooling. Pooling is nothing but the more information retrieved from the respective field. And the second convolution, you can put n number of convolution. That depends upon how many convolution layers you can define. If number of convolution layers more, the computational complexity will be the high. And fully connected neural network, then find out. So dog is equal to 0.01, cat is equal to 0.4, boat is equal to 0.94, and bird is equal to 0.02. So what does it mean interpretation? Interpretation says that the 90% or 94%, right? 94% images looks like a boat. So the probability of the images is boat is 94%. So in this way, we can find the nonlinearity. The pooling will come to later, so you will not understand here. Let me consider this one. So this is a beautiful animal. We can call the koala. This type of animals are visible at South Africa. Suppose the image size is equal to 1920 into 1080 into 3 high quality images. Is a fast neuron. If you use the artificial neural network, it will comes under 600 million neurons. Then if you use the hidden layer, then it will be 4 million. So total is equal to 24 million, because every weight multiplied by every input, right? Now imagine if 24 million input you provide to a neural network in your system, definitely you take 10 years time. So that's why out of 24 million, how much data are really participated in the experimental work? That is a convolution you have to do it. So what we'll do, total koala, you can divide the image. So we can call the here image of the head, image of the leg, we can find out. Then jointly you can divide it, and each image we can identify whether it's a koala eyes or koala nose or koala head or not. Then you can go segregate it, then you can find the koala face. Suppose this is the koala head, you can find. So this is the kernel size, and multiply this -1 into 1, -1 into 1, 1 into 1, 1 into 1, slider multiply. Then, so -1 by 9 is 0.11. You find 0.11. Similarly, next, the sliding will come here. Again multiply. Again you will get the value. And this is nothing but the feature map. This is nothing but the feature map. And this feature map is different image to image. That means for head, for neck, for eye, for nose, for ear, hand and legs will define. Then our head detector is there, 1. See, eye detector, nose detector, ear detector is 1, 1, 1. Then filter ahead, so this is 1. So up to this part is called the feature extraction, and the input is the fully connected neural network. Then you can find whether it is a koala or not. That's the feature extraction. Now, as I already told you, the convolutions and ReLU and poolings. Now coming to the pooling, what happened? So the feature value you can find out. Many type of poolings are there. One row sum pooling, column sum pooling, then average pooling or max pooling, like that is there. So 3 to 8, 9. So 3 to, what is the maximum value? 9. Extract the 9, 9. Again, sliding is there. You can slide is equal to 2. So 2 column you have to leave. Then you can find in 2, 5, 9, 5. So highest is equal to 9. Make it is 9 here. Then again 2, 5, 9, 5. You can do 2 sliding, 5, 6, 5, 3. So 6 is there. Similarly below 8, 9, we can call the 4, 4, 1, 1, which is minimum 4. Then we can find the 6, 8, 2, 1, the maximum is equal to 8. Now you see, this is a 4 into 4, 16. How to reduce to 4 into 4? So this information is nothing but the pooling. Now you can put a question, sir, many informations are lost. Information loss. Information means those are real value information. Those are high strength value that will be extracted and put in next carry forward. So similarly, the pooling we can do many times. Average pooling or max pooling or any pooling can do. And pooling will be reduce the height and width of the feature map so that the density of the feature map remains unchanged as shown in the figure. Now you see here what happened. The density is not changed. The value will change, so density not change. And the pooling operation independently carried across the depth of the program. Now coming to the one of the very cited example, we'll explain. This is one of the very good paper we can call. Around 600 citation is there. So here what you did, one of the I'm going to explain one of the published work. We have used the CT images as the lung cancer. Around 500 images, CT images we collected across the hospital, and male and female we also collected, right? Then these are the details. So these are the lungs. You see, any abnormal growth in your any part of the body is not a cancer. Any abnormal growth tissue of any part of your body is not a cancer, unless until you do not go for the biopsy or the CT scan or the medical diagnosis or a medical trial. You can call it a cancer. All cells is not a cancer cell. So what we'll do, the CT ratio, when you find out the individual age is equal to 32 to 48 years, and the male is equal to, we can call 70%, female is 22%. So the statistical data. Our data, here the symptoms no need to discuss here. So our data will tell us 94% accuracy on our model. So what is the novelty of our work? The novelty of our work is experimental setup in a methodology. So what we did, we extract the features from the patient data set, and that features we extract different way. For example, histogram features, texture features, and wavelet based features. Directly we have not implemented. We implemented after feature extraction using linear discriminant analysis. We identify the histogram features. Histogram means the variance, mean, then standard deviation, then kurtosis, then squishness. We identify. After that, what happened? Texture feature also you can find out, like entropy, then homogeneity, the contrast, and the correlations. Then identify the wavelet based features. So all the three features we passes to the our own model with some existing model. And our data also validate with some existing models by using ODNN, optimal deep neural network. And this study also compare with some existing work that is called deep belief network and restriction bold machines. And this part we call how the CT database, so images, all the images, 500 images, we pass the pre-processing. After pre-processing enhanced images, the feature extraction, then you passes the LDA, linear discriminant analysis, just like a principal component analysis. Then the reduced feature, and the reduced feature, I passes to the CNN. So this CNN is nothing but the optimal deep neural network, and optimal deep network passes the features. What are the features we collected by these three methods: histogram feature, texture feature, and wavelet features. Then we identify, we got our result revealed that normal, benign, and malignant three-class problem, and on the basis of three-class problem, you can identify which one is benign and the malignant. And this is nothing but after CNN output, input to the reduced feature. So this is not the CNN, remember. What output I'm getting here, again input to the, so that's why I make the reduced feature. Look at here. That's what the reduced feature. Here, no reduced features. Here, number of features are there. So this is called the reduced feature, right? And this is called the ODNN. This is the details I'm discussing ODNN. In this ODNN, what we'll do, ODNN stands for optimal deep neural network. And we will use the input header layer and the output by using, we can call the optimum DNN, optimum deep neural network. You find the loss function, they can find the evaluate the fitness function, then the consider the satisfy constant, then generate the initial agent we can find. Then output should be, we can call the class 1, class 2, class 3. And class 1, class 2, class 3 is nothing but normal and benign and malignant. So what is the output data set you see? So we can validate our data having k-fold cross validation. So what is k-fold cross validation? We divide our data all the data. Suppose you have 100 data is there. So first 1 to 10 training and 11 to 100 testing. Similarly, 1 to 20 training and 21 to 100 testing. Similarly, 1 to 30 training, 31 to. So in this way, what happened? Why you do? Now all the data point participated training as well as the testing, right? So both are all the data point participated training as well as the testing. So we get the result at the k value is 35. The accuracy is little bit higher than other k value. See the k value 40, accuracy 95.45, where k value 35, 96.52. So these are the different existing model. We use the deep neural network, we use the KNN, then use the artificial neural network, we use the linear, we use the radial inverse function, we call the multilayer reception, multilayer perception, then you use the ODNN, optimal deep neural network. So out of all this method, our method are not given the 99% accuracy, but little bit 96.52 accuracy is there. We are satisfied with our results. So here conclusion that the proposed ODNN model feature reduction or demonstrated better classification long city images. We can help to those are domain knowledge expert, those are oncologists, okay, those are oncologist guy. So we can doctor will be helpful to the doctor. So for decision making. Then another set of example. So this is also recently done 2025. Evolution of deep neural network detects breast cancer using histopathological mammogram images. So mammogram images, histopathological images, the data set we can consider by the ultrasound as well as the CT images. So we can find out here. So we just compare here is one of the PG student work. So we just compare all the latest we can call the CNN techniques. So latest CNN techniques, Alex Nand and BGC techniques are there. So they are the tumors, right? So we can find out. So you can easily identify the tumor of the breast and which part of the breast tumor is there. You can easily localization of the Alex Nand architecture. Now the study includes that apply the BGC is more prominent method as compared to the other existing method with the lower accuracy. Now another method is there. We can call the extension work of the here. So here what we'll do, we'll find the GLCM work. GLCM means gray level co-occurrence matrix. We have to compute here. So fuzzy semin we can apply. Why the fuzzy semin? The data set we are not boundary are fixed. So data set may be overlappings are there. So we apply the fuzzy semin. Then after that we apply the fuzzy level coherence matrix. And our accuracy become 98.3. So a little bit we increases the previous one. Same data set we have considered here. So there are the input images. Pre-processing is a medial filter, Gaussian filter. We can 2D and mean filter. Pre-processing are there again D. Then go for the segmentation because the K-mean and position clustering. Then apply the feature extraction on the GLCM technique. So GLCM nothing but your gray level co-occurrence matrix. Then after that you can accuracy you can predict it. So there are the find out, we see the mean and median value, total image is going to be taken 20. You can extend the higher work also. Now, see these are the images and get the output will be the maximum, the more accuracy of this output. Now, coming to this another work, you can find the design efficient model of the survival prediction of brain tumor patient, generative advisor network. So the is nothing but the higher than the we can call the latest techniques is compared the neural activity of the SOS operation, right? So in this case, what happened? You can say the brain tumor we consider. Then you can find out the model activity of the proposed classification process. Here you can find the generator of the input layer. After that input layer, data processing, general advisor network. Then pass the neural activity and adaptive comparison of time transformation and squeeze and extraction technique you have done. After that feature extraction, then you can find the output of the prediction. This is nothing but the image set analysis of the significance of the overviews. Now the output is nothing but you can tell that over the our data is nothing but the over observe the delay 90% brain tumor instances will be a little bit higher than the other model and our proposed model give the data set at 12 to 14,000, and accuracy will be the little bit high, 83.74, as compared to the other existing method. Now another to work, you can find the brain tumor segmentation. Same thing work. The one is, I think, Microsoft. Okay. So demonstration is there. I can show the demonstration how it work. Yes. The sound is visible. You just tell me sound is visible or not.
Hello. Today I am going to.
Is sound visible?
Yes,
Hello?
sir.
The audio visible or not? Readable to you? Listen to you?
Yes, sir.
Visible.
None.
First initial step I have taken.
So this is the how CNN implementation I explained.
So those data sets I have put it in one folder, and that data path I have copy pasted here. This environment is MATLAB environment. We have another environment also, Google Colab or Jupyter Notebook, where we can do the Python coding. But this is a MATLAB environment. So here first I have saved the data set in the D drive. So that data set I have loaded over here. And inside the folder, whatever the subfolders are there, and whether it is of JPEG, PNG, or any other TIFF file or DICOM file, any other file, it will able to read the data set thoroughly. And I have training the data set I have split as 70%, and training image and testing image I have been splitted. And now here I am building the CNN model. Here I am building the CNN model. I am taking the layers of the CNN. First I am taking the input layer, next convolutional layer, batch normalization, reloop, and max pooling layer. Later on the next convolutional I am taking, like it's a multi-layer convolutional. So after the convolutional part is over, with the batch normalization, reloop, and max pooling, I went for fully connected layer. So here there is a binary, like two folders are there. One is tumor and another one is not tumor. So that's why I mentioned here as two fully connected layers. And classification layer I am showing. Now these are all layers. Whatever the layers are there, I am making as options as my variable I am making it. And where stochastic gradient descent optimization I am using. Initial learning rate I have taken as 0.00 and max hypothesis I have taken as 50. And continuing the process like with the validation data, test images, validation frequency, and any false positives are there, and training progress, everything I have made it in one syntax. And these all are the training options. These all are for the training options of the algorithm. And later on, I am making it in the plots. These plots, this plot shows tumor images and non-tumor images. It has been clubbed up, and it will take the random images now. So whenever we run this environment, it will ask for test image to pick it. So at the time we have to pick the tumor image, it will show the tumor part, and if you pick the non-tumor image, it will show the non-tumor part. And also will segment the tumor where exactly the tumor is there. So this is the code for the test. This is code for the test running, and whatever the net we have used here, this net is from here. This net is from here actually. Whatever the net we are using, that net we are here. So no, actually this is the net. This is the net we are using, training images and the layers and options we are using. So this is for the scenario. Here I am using the classification and net and image, original image. .5 we are taking, and all the labels of MRI image we are taking, and whatever the plots we are plotting has, one is original MRI image and another is tumor alone, and whether if there is no tumor, then it will show as no tumor. So now if we run this environment, we will show all execution part over in this command window. Somewhere this. Yeah, I have copy pasted. If I click on run, now the code is executing, and it will read all the formats: PNG, JPEG, JPEG, TIFF, TIFF, whatever the different type of image formats are there. All those image formats it will read. So it is keep on running. It is keep on running. This environment will show if it is busy. Here it will show the busy. So it is running background. It is running behind. So these are the sequence of CNN, whatever we have seen, the code.
Now you see how the output is coming.
These were training the process, and here you can see the iterations. I have taken small iterations 50 because let this process complete very soon, as it is a demo to show how to execute the video. That's it. See the training, it has been reaching up to 100. It is training well. So it will go to 50 epochs, and at 50 epochs, we may get accuracy around 80 to 90 in between, because if one increase the iteration, the accuracy will increase. So it will be in between some 80 to 90. I hope so. Somewhere it is 83, 88, 83.33. So now a test image to select, it will ask, see all the images, tumor, 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 and tumor. And if we run again, it will select randomly, tumor one, non-tumor one, like that. It will keep on selecting. Now if I select the tumor part, let us suppose think this one Y7 is a tumor image. If I open it, see, this is how it will show. MRI original image, tumor alone, and detected tumor. You can see MRI original image, tumor alone, and detected tumor. Now for suppose if we run again, now let us take a non-tumor image. If we take some non-tumor, 5 has no tumor. If we open it, if we run again, if we take 0 non-tumor images, if we take, see, it will show as, see, no tumor. It will show as no tumor. Like this, this code will, if there is a tumor, it will show as tumor. If there is no tumor, it will show as no tumor.
So you see the how our work is done by this method. Now, so what I told, explain you the CNN work. That is the experimental I recorded, and I explained how the CNN work. Now the common symptoms of the tumors I already know, the brain and lungs, and basically these are the clinical evidence are there. So they are having different type of symptoms of the tumor, the early stage of the tumor, and the scientific another paper also there. You can find the joint transfer learning and the multimodal medical images. So we can find so same thing. We can find different type of methods, or we can the PCD approaches. So same process. So this is nothing but the histopathological images. That is a sample images, so the ultrasound images. So below is the ultrasound images, and above is the histopathology image data set. Then we can find that our malignant, average, and benign. So we can find the result, or result little bit higher accuracy than the 97.8 as compared to the other existing method. So time and accuracy methods are there. You can see. Now, what is conclusion that our computer vision method, a fusion technique, so we can call the data to large language model, people are doing that, right? So same thing you can find the fusion techniques, data fusion, joint transfer learning. Breast cancer diagnosis is more recent techniques in case of histopathology and the ultrasound databases. And AI make a cancer treatment more effective or improve the quality of the life of the patients. And as the technology continues, the involved and the day by day, the potential of AI in the further revolutionary and radiation therapy and other area of the healthcare eminence. Then current limitations and futures in AI radiation oncology. So he's saying that 70% cases are low and middle income countries are there. So people are getting very less, not too much financial sound. We can go for any high quality treatment and go for long times the disease prognosis poor survival and shortage radiotherapy workforces. Then counseling is required and the awareness required nowadays to all the peoples. Those are very, very poor and sitting in rural area. They don't know what exactly cancer means, right? So WHO and IAI call radiation success up to the 85%. So these are the equipment. This is the brachytherapy and a 2D based IMRT in the intensive modular test RT radiotherapy. So we'll increase willing the automation is helpful. People are saying yes, it will be helpful. The quality of planning also required more. Systematic errors should be reduced, and random human errors must be also should be reduced. Will AI the automatic automation will be helpful? So people are saying the automatic will be provide the positive benefit of your dependent, but being a expertise, you have to take the help of AI. So don't take the decision of the AI. So you take the help of AI, you take your own decision as per your domain knowledge, right? That is the more concerning. So AI radiation oncology, so you can find the challenges or resource intensive, then the time consuming, operator dependency and learning curves they require. So these are some limitations of AI. Target volume delineations you see. So the mouth cancer, so some images are there. Then you can find AI symptomatic of CT generation, MR only the workflow of generation of systematic CT, CSCT or the CT, we can find out. Then AI for the planning. The clinical integrations are required for the machine learning for curative intense radiation treatment patient with the prostate cancers. The limitation of AI planning is also there. Small training of the validation sets. We must be validate your data and the development of validation signal record the cancer of the cerebromix. And AI plan the commissioning the machine performance check. The treatment delivery large amount of data is required. Then AI based solution review automation based development. After post treatment also AI quite helpful for the how to survive for long models for the AI required the help to improve the efficiency or implementation treatment the reduced error. These are the brachytherapy, as I already told you. So brachytherapy is the advanced part of chemotherapy, the radiation therapy is one type of radiation therapy, advanced version of radiation therapy. Only targeted part of the radiation therapy and brachytherapy workflow facilitated by the AI input. Then it automatically count, you give the body weight and all the physical parameters. The brachytherapy will tell exactly how to do it in a treatment way. Radiation oncologist judgment may be more accurate with the help of AI tools and AI basically the facilitate to the expert domain to take the decision. Otherwise, what happened? The expert domain to lot of clinical trials, a lot of things should be required to overlap. Radiation oncologists will remain responsible in change of entire treatments limitations. And concern is that quality of the data. So data must be in genuine data. Data should be inaccurate and applicable to algorithm across the various clinics. And data should be in privacy should be maintained. Challenges: the clinical utility of AI should be determined. All the developmental, technological, incubation up to clinical establish clinical value. And patients should be privacy, anatomy, and ethics. Will AI replace my job? So that is so no AI may be needed change the nature of the some job. So AI will make a free other jobs replace. Then taking and counseling the patient and examining the patient, clinical management, reduce wait time to the meet doctor. So that will be the help. How to teach the younger generations? I already told you these things. I think limitation across the AI. I told you advanced AI overcome the limitations. So these are the future job profiles. I already told you now future of AI. So we can let us join with the AI to the better featurement and well-being to the society. How does the future look like? So the conclusion. Any questions? So as I think I cover a lot of things in the 1 hour. So 6 and 45. Okay. Any questions? So I'm happy to address some questions.
Madam already introduced herself. I request all of you, if you have any doubt in this session or if you want to clarify anything, please ask our professor. He's there to clarify your doubt. Any question, please? Sir, I think all of understood your session completely and thoroughly. So in the test, we can see how much they wanted and how much they have understood. So any question, please? Sir is there online with us.
I think there are no questions. So I think they are prepared for the second session, 8 o'clock start, right?
Thank you, sir. Thank you, sir, for such an engaging and insightful session. We deeply appreciate your valuable contribution. Then, dear participant, we request you to kindly provide your valuable feedback for this session. Your feedback helps us to improve and also encourage that AICTE requirement are fulfilled. The feedback link has been shared in the chat box, also in the WhatsApp group. I request everyone to complete it within next few minutes before we move to the next session. Thank you. Thank you, sir.
Thank you. So I can quit the meeting, right?
Yes, sir. Yes.
Okay. Thank you very much, madam.
Sir.
Thank you.
Our next resource person, Dr. Sujata, is joining shortly. So please stay. And when madam will come, she will start her session. Okay, madam joined us. Yes, madam. So, ma'am, you can start your session.
Okay. So can I just switch up my audio? There may be some bandwidth problem here. So can I switch off my video? Rupali,
Ma'am?
can I switch off my video?
Yes, ma'am. You can switch off and you can show the PPT whatever you want to share.
Yeah. Stop.
Okay, ma'am. Okay.
Okay, thank you. Hello, my slides are visible?
Yes, ma'am.
Okay. So good evening, all of you again. And I'm going to start my uh, lecture, which is an introduction to computational intelligence and its applications. So, in your area might be different. All of you are from power electronics, but my application may not deal with that power application, uh, electrical problems. But some of the applications I'll try to explain you through using computational intelligence, which will help you to understand your problem, the problems from your own area of domain. And the outline of my lecture is I will start with a small introduction. What is computational intelligence? Then we'll explain some key characteristics of computational intelligence. Then I will come to the components of under the components of CI, of course, I will explain you artificial neural networks, fuzzy logic, evolutionary computation, swarm intelligence. Then the application of these components of computational intelligence. I will conclude my lecture with the application. So, first, let me start with a small introduction. What is computational intelligence? As you know, it's a very broad field, broad area, which refers to a collection of nature-inspired solving techniques, and those techniques are especially designed to handle complex, dynamic, and uncertain problems where you find the traditional rigid algorithms do not work. They fell in those while solving those problems. We cannot apply this traditional or the rigid algorithms. They will not work properly. So we require this nature inspired or this computational intelligence technique to solve these complex dynamic problems. But if I come to AI, as you know, classical artificial intelligence depends more on symbolic logic, explicit rules, and expert systems. But CI, computational intelligence, it emphasizes or it uses the soft computing approach. So now you can find the difference between AI and CI. Of course, it's a very small difference which I explained, but as I proceed, you will get to know what is the major differences exist between these two. Then soft computing, as you know, it doesn't seek exact solutions. We apply the soft computing techniques to real life problems, and in real life problems, we cannot find exact solutions, but we can find approximate or adaptive or the solutions which are very tolerant. So that means just like the human being find the solution for a natural for a problem which has a lot of uncertainty. So The subcomputing techniques or the computational intelligence finds the solution which is closer to the way human beings find solution for a natural system. So now let me tell you some computational intelligence uh, components. Of course, I will again come to explain all these components in detail. But now, while giving the introduction, let me tell you the computational intelligence. It draws inspiration from the biological processes, some from evolutionary processes, and some natural processes. So, for example, one of the CI technique is your neural networks, and neural networks is modeled after the human brain, as all of you know. And the neural network learn patterns from the data, and are especially powerful in recognition, prediction, and classification task. And the second component is fuzzy logic. It deals with reasoning that is approximate rather than fixed and exact. So that enables computers to work with linguistic variables. So, for example, the linguistic variables like high, medium, low, rather than just using binary values true or false. So, this is the advantage of fuzzy logic. And third component is evolutionary computation. In evolutionary computation, you can find genetic algorithms, swarm intelligence, etc. And this evolutionary computation is inspired by natural evolution and the collective behaviors. These approaches explore large solution spaces and optimize the performance. Then, coming to artificial immune systems, uh, this is inspired by the adaptive immune system to detect anomalies and handle dynamic environments. Then the last one is hybrid system. The name itself says like we are hybridizing or combining more than one system. So if I say neurophagy system, that means we are combining the methods of neural network and Fauci. So to leverage the strength of both the approaches. I mean, you can combining multiple the strength of multiple approaches and developing a hybrid system. Now coming to the characteristics. Uh, Characteristics include adaptability. What is adaptability? The as you know, the CI systems can adjust to changing environments. That means it can adapt to the changing environments without explicit reprogramming. That is the most advantage. I mean, the plus point of this particular in CI. And next is fault tolerant. So, what do you mean by this fault tolerant? It is capable of producing acceptable results. This is called fault tolerant. And the third one is learning ability. So, what is it? Learning ability means the learning, because of the learning ability, the system performance improves over time through experience. Then, next is approximate solution or approximation. Um, CI doesn't produce exact answers. Instead, it focuses on good enough solution, the solution which is acceptable for the problems where exact answers are either impossible. Why we go for this? That means we do not find exact, it's quite impossible to get the exact answer, or maybe if it is possible, but very costly. So in that case, we go for this approximate solution. Then the next is robustness and complexity. It handles nonlinear, highly nonlinear, and high dimensional and dynamic problems very effectively. So this is a brief introduction. What I just what I thought of giving you to start my lecture, and then let me explain what is the difference between traditional AI versus computational intelligence. So, first, let me tell you something about artificial intelligence. So, when we talk about AI, we usually mean, or usually we try to mean teaching the machines to show intelligent behavior, trying to induct intelligence into a mission. It is something similar to how humans think and act. For example, AI can play chess, recognize your voice on a smartphone, or recommend movies on Netflix. So the focus here is on making machines act smartly, or to think, or to learn and solve problems like human being. But let me come to computational intelligence. So computational intelligence it's a special branch of AI, but it works a bit differently from AI. Uh, Instead of giving machines strict rules to follow, the way AI does, CI looks at how nature itself solves problems. So just think of how birds flock, ants find food, or the human brain adapts to new situations. So CI tries to copy these natural mechanisms to make the machines more smarter in the environment, which are very complex and always changing. So the key difference between these two are, first, if I take AI tries to create machines that can mimic human intelligence. Also, it works well in structured situations where the rules are clear. For example, an AI chess program follows logical steps to win the game. Coming to computational intelligence, which focuses on adaptive methods, which is inspired by nature. And it excels in unstructured, uncertain, or constantly changing environments. For example, a self driving car using neural networks adapts to traffic, weather, and unpredictable road conditions. So these are the different. This is the example of CI, and these are the differences if you compare AI with CI. And then coming to common applications, what do you find here? The difference. So, applications of artificial intelligence, if we discuss about it, then AI has become part of our daily lives. All of you know that, often in ways we do not even notice. Some common applications of AI includes speech recognition. Everyone is very familiar with this. Like all of you must be using virtual assistants like Siri, Alexa, and Google Assistant that understand your voice and respond to your command. And coming to another application, handwriting recognition, systems that convert handwritten notes into digital text, such as Google Lens, very, very popular nowadays, or banking check processing. Third one is optical character recognition. It scans the printed documents and converts them into editable text. Then next is machine vision. So what is machine vision? AI in cameras, available in cameras, robots, and quality control systems that can see and analyze the objects or images. Then natural language processing. You can find the application of this in chatbots, translation tools, and sentiment analysis system that understand human language. Then big data solutions. AI also helps analyze massive data sets to find hidden patterns, predict the trends in the data, and support decision making. So these are the application of AI, some of the applications. And now coming to the application of computational intelligence, I can say CI is more about adaptability and solving real world dynamic problems where exact we find difficulty in finding exact answers. So some of the applications here are intelligent household appliances, like washing machines. You know, the smart washing machines, they adjust the washing cycles automatically. Or the smart refrigerators, they can suggest your shopping list. Second is medical diagnosis. Systems that use fuzzy logic and neural networks to assist doctors in detecting diseases early and recommending treatments. So, early detection and also recommendation of the treatment can be done through this particular using this computational intelligence technique. So, and the third one is banking and consumer electronics. In this application, fraud detection in financial transactions can be made, and adaptive features in smartphones can be introduced. TVs are recommendation, adaptive features in smartphones and TVs or recommendation systems can be developed through this. Then optimization applications. Uh, Actually, CI techniques like genetic algorithms, it helps hard problems in scheduling, logistic, and resource allocation problems. Uh, so through this, the parameters can be optimized in these problems. So the application that like it can be used for optimizing the applications. And the next application is industrial. It can be also applied in industrial problems for like robotics, fault detection, and process control in manufacturing plants, where we find the environments are uncertain and constantly changing. So these are the different application, common application of AI and the real life application of CI. Now let me take you to another. What are the key characteristics you find in CI, computational intelligence? So the first characteristics is here I'm going to discuss is the ability to handle uncertainty and imprecision. Uh, in the real world, as you know, data is not often you find the data which is incomplete, which has noise or vague data. So, for example, mm, a doctor might say a patient is having high fever. Instead of saying what is the amount of fever, like the exact value of the fever. So this is it's a vague data. Or the information which is given by a doctor. Similarly, weather forecast often deal with uncertainty. Like if I say there is a chance, 30% chance of rain. Okay, so that means it is not certain that you will get. There would be rain or you will not get rain today. So there is a chance, and that too chance is 30%. So this type of data can be, uncertain and imprecise data can be handled by this computational intelligence technique. Traditional AI usually struggles here because it expects exact rules and clear inputs. The inputs must be clear. So the computational intelligence, however, can deal with this uncertainty. Fuzzy logic allows systems to work with approximate truths rather than strict yes or no answer. This makes the computational intelligence systems more flexible and realistic because they can make useful decisions even when the input data is messy. So I can say CI doesn't demand perfection. It works with the kind of imprecision we the human being deals with every day. And second one is learning and adaptability. So this is one of the most powerful features of CI is its ability to learn from experience and adapt to new situations. So neural networks, as you know, it learns from large amounts of data, just like the human brain. For example, uh, I mean, the neural network, uh, when we use for recognizing the suppose one image, so the improvement, they improve to recognize the face when you when you provide more number of images of the face to the system, to the neural network system. Similarly, evolutionary algorithm mimics natural selection. So um, it tries with many possibilities and gradually improving over time. That means when we use evolutionary algorithm, we provide, we create a population, and in that population, many chromosomes or candidates are available, and out of those candidates means they are the possible solutions. So but out of those possible solution we find the best solution, and that best solution can be obtained over time. So the way the species evolve uh, in um, in the natural evolution. Similarly, here the evolutionary algorithm help us to find an improved solution over time. So this means computational intelligence system do not just follow the fixed rules; they change, they adjust, and improve automatically as the environment or the data available changes. Then next is robustness and fault tolerance. So these characteristics of the CI system can still function effectively even when some components fail or the data is corrupted. So this is one of the biggest strength of CI, is its ability to keep working even when things go wrong. In real life, data may be noisy. You can find some incomplete data or even corrupted data. Traditional AI cannot deal with this kind of data, but CI techniques like neural networks or fuzzy systems are designed to be fault tolerant. For example, a face recognition system using CI can still identify a person even if only a part of the face is covered. I mean, part of the face is covered, still the the system using CI can able to identify the person. Suppose the person has, wear a sunglass or a mask. In that case, also, the system having CI, using CI can could able to recognize the face. And then next is nonlinear problem solving. So most real world problems are nonlinear. They don't follow simple straight line cause and effect relationships. For example, predicting the weather, optimizing airline schedule, or modeling the stock market involves thousands of interacting variables. Similarly, classical algorithms struggle. In this case, for this kind of problem, if we apply classical algorithms, they will struggle here because they are better suited for linear or the rule based problems. They cannot deal with this kind of uh, complex problems. But CI techniques like evolutionary algorithms, swarm intelligence, and deep neural networks excel uh, at handling this type of complex high dimensional problems. So in a nutshell, I can say CI is like a problem solver that can handle messy real world systems better than traditional math based models. Then comes approximate reasoning. Unlike the classical logic, all of you know about classical logic, so I'm not going through that. So, unlike classical logic, which only allows yes or no, true or false answers, CI allows decisions to be made in degrees of truth. For example, a thermostat doesn't just decide hot or cold. With fuzzy logic, it can say temperature is somewhat warm and adjust the cooling smoothly. This is extremely valuable in human like decision making, where situations are not always black or white. So, CI can make practical human like decisions in uncertain situations instead of demanding exact answers. And next is optimization capability. Many real world problems involve finding the best possible solution among countless possibilities. For example, designing airline schedules, optimizing delivery routes, or logistic. There are many routes. You have to find the optimum one. Similarly, there are many schedules can be prepared for the airline, but the optimized schedule must be prepared, and that only can be prepared using the CI techniques. Allocating resources in industries or healthcare. That is also possible using this CI tools. So traditional algorithms often fail because the search space here is, the search space means the possible solutions. Here is too large and too complex. So in this kind of search space or the possible solutions cannot be, or your traditional algorithm cannot deal this kind of solution. So here is where evolutionary computation like genetic algorithms and swarm intelligence like ant colony optimization or particle swarm optimization works wonderfully. So they mimic natural processes such as the evolution, mutation, or the way birds flock and ants find food. So instead of trying every option, they explore smartly and find optimal or near optimal solutions efficiently. So CI is excellent at solving hard and complex problems by finding the best fit solution, where traditional methods would be too slow or may fail entirely. Then next is self-organization and emergence. So what is it? In nature, we see amazing collective behavior without any single leader, without any leader. So what the examples are birds flying in flocks. There is no leader you find when the birds are flying in flocks. So it is a collective behavior. The technique of collective behavior has been, we can find in birds flying in flocks. Similarly, ants building colonies and fish swimming in schools. So this happens through self-organization. Each individual follows simple rules, and from this, complex intelligent patterns emerge. So in swarm intelligence, CI applies the same principle. Systems adapt and reorganize themselves automatically without a central controller. This makes them flexible and highly adaptive to the changes in the environment. Then, what are the components of, okay, let me come to, oh, yes. What are the components of computational intelligence? So, these are, you can find ANN is one of the component, fuzzy logic is another component, swarm intelligence, and evolutionary algorithms. So, these are the different components of computational intelligence. Now, coming to each of them, let me start with ANN. So, all of us know this ANN is inspired by the human's brain structure, or ANN as a computer's version of the human brain. You just think as a computer's version of the human brain. Just like our brain learns from experiences, ANNs learn from data and examples. So once ANN is trained, they can adapt to new and unseen situations. So making them powerful for solving problems where the rules are not clearly defined. Then where do we use ANN? So what are the different applications where you can apply? Already I have told you pattern recognition, handwriting, for identifying handwritten digits or spotting cancer cells in medical images, and image processing. You can use it in facial recognition and object detection. Also, you can use ANN in natural language processing, like power chatbots. You can develop chatbots, translation of tools, translator tools, and voice assistants. Then prediction task also can be developed using ANN. Stock market forecasting with the prediction can be predicted. You can forecast these problems using ANN. And then the next one is fuzzy logic. It deals with uncertainty and approximate reasoning. In real life, things are rarely just black or white, true or false. You don't find in that way in real life. There are, there are always shades of gray. Like fuzzy logic embraces this uncertainty. It works with degrees of truth, that is, something can be 70% true and 30% false. So then where do we use this fuzzy logic? We can use it in control systems like washing machines that adjust wash cycles depending on the dirt level, or air conditioners that balance cooling. And similarly, we can use it in decision support system, helping in medical diagnosis or business risk assessment, whereas answers are not absolute. Also, it can be used in consumer electronics, like cameras with autofocus, smart TVs, and many more. So fuzzy logic is like, in a nutshell, I can say it is like human common sense in machines. We are just putting human common sense in the machine. It handles uncertainty and makes flexible decisions instead of rigid yes or no outcomes. Then let me take you to evolutionary computation. Okay. Evolutionary computation. Evolutionary computation, it is based on Charles Darwin's principle of natural selection, or we call it survival of fittest. And the system evolves solutions over generations by applying certain operators, which are mutation, crossover, selection techniques, and Similarly, the popular techniques of evolutionary computation is genetic algorithm. I will explain genetic algorithm elaborately after a few slides. Then swarm intelligence. And swarm intelligence, just 1 minute. The swarm intelligence is inspired by collective behavior of ants, bees, and birds. And here, there you don't find any leader. It works in a decentralized way and using applying self-organizing principles. And the application of swarm intelligence you can find in robotics, routing, mechanism, clustering, and optimization techniques. Then supportive techniques. So supportive techniques here, apart from the main components like ANN, fuzzy logic, swarm intelligence, you can find some supportive techniques that often work alongside or extend the CI methods to make them more powerful. So some of the supportive techniques are reinforcement learning. Here the learning happens by interaction with environment using rewards. So reinforcement learning is like learning by trial and error, just the way humans and animals learn. The system interacts with the environment and learns through rewards and penalties. For example, a robot learns to work by trying the movements. When it moves correctly, it gets a reward. When it falls, it gets a penalty. And second is probabilistic reasoning. Sometimes data is uncertain or incomplete. So probabilistic methods help machine make the best possible decisions under uncertainty condition. Tools like Bayesian networks or markup models calculate probabilities of outcomes and guide decision making. Any problem? Hello? Hello? Hello?
Yes, ma'am. No problem.
Okay.
Yes,
So,
ma'am.
okay. So some of the examples are predicting disease risk in healthcare when patient data is incomplete. Similarly, speech recognition systems guessing the most likely word you meant. Then third comes hybrid systems. No single CI technique is perfect for all the problems. So researchers combine them to form hybrid systems that balance the strength of both the uh, tools. For example, neurophagy system. Here we are combining neural networks and fuzzy logic, develops a system that learn from data and also can handle uncertainty because we are using fuzzy logic. Similarly, genetic fuzzy system. Here we are combining evolutionary algorithms and fuzzy logic that helps us to optimizing the decision making under uncertainty. So different CI methods working together to solve complex problems, real world problems. When they work together, they handle more complex real world problems effectively. Then comes, yes, now I'll take you to, explain artificial neural network in detail. I'll just discuss how this, what are the different type of neural networks we have, and even the structure of ANN and applications of ANN. So let me start with neural network. So neural network, as already I have told you, the inspiration we have taken from the brain, human brain. And just like our brain has billions of neurons connected in a network, ANNs are made up of artificial neurons. We call them nodes, and they are massively connected and connected by the links. That links we call them as weights. So each of the neuron, they receive inputs, then process them using a function and passes the output to the next neuron. So I think all of you must know that the function which when the input we receive, the neuron receives, then the neuron has a summation function. All the input, each of the input will be multiplied with the corresponding weight, and then it will be added to the next input, weighted input, which comes from outside to the neuron. So all the inputs multiplied with its corresponding weights, then all of them will be added together or summed up here through the summation function. Then once the summed, I mean the weighted sum of inputs are computed, then it goes through another function which is called the activation function. So activation function process this weighted sum of inputs, and then it finds the output for the neuron. So then once it is done, then output layer produces, okay, let me tell you, the structure of ANN, it has, the structure you can find in the structure of ANN, it's a layered structure. I mean, you can find input layer, and there may be more than one hidden layers in between input and output layer. And the function of input layer is it receives the raw data, or we call them as features. And then the hidden layers, it perform transformations and extract the patterns through weighted connections from the data. And the output layer produces the predictions, or it makes the classification. So each connection has a weight, and each neuron has an activation function. So that determines the output. Then let me take you to the history of ANN. The evolution or the history of ANN, if I start, so it started in 1943. McCulloch and Pitt's model introduced in 1943. This is the first mathematical model of a neuron. Then in 1958, Rosenblatt introduced perceptron. This is the first trainable ANN. And then in 19, of course, 75, another, Verbus developed backpropagation to solve the jaw problem in the perceptron model. But again in 1980, backpropagation actually, the breakthrough that allowed ANNs to actually learn effectively, that was introduced in 1980. Then in 2000 onwards or 1992 onwards, deep learning with more data and computing power, ANNs grew into deep neural networks, and then empowered the modern, that means added more power to modern AI. Then coming to the architecture of artificial neural network, this is the way we design the neural network architecture. So input comes to the neurons which are in the input layer. We call them as input layer neurons. And then the input layer neurons simply forward the input to the hidden layers. I mean, it comes to the hidden neuron, I mean, to the next layer, which is called hidden layer. And here, each of the neuron has two functions, summation function and activation function. Again, you know, activation function may be linear or non-linear. If the problem is linear, then you may have linear activation function. Otherwise, the activation function will be non-linear. Then the activation function will process the data, and then it will forward the output of first hidden layer will become the input for second hidden layer. Then second hidden layer will process it, and then it forwards to the next. Then after processing of hidden layers, the processing of the neurons of the data overs or completes in the hidden layer, then it goes to output layer, and output layer finds the classify the problem or finds the output. So this is the architecture. Then coming to key elements of um, artificial neural network. So neuron generally single neuron is called perceptron. This is the basic processing unit, and that applies weighted sum plus activation function. Already I told you, in every neuron you will find two function, summation function and activation function. And summation function, that means the neuron, when the data input data, when it comes, it is multiplied with the connective, the weight factor which is connect to that, and then it enters to the neuron. And we call the input what which comes to the neuron is weighted sum of inputs, and then it goes through activation function. Then you can find another element, weights or and biases. These are the parameters learned during training. You cannot change the input. Input will remain always constant, but weights and biases are the parameters which you can change. So that means learning happens to weights and biases, so that you could able to find the most the what mm, effective or the approximate result which is very near to your desired result. Then activation functions, it decides neurons output. Maybe you can find sigmoid activation function, ReLU, TANH. There are many activation functions. Depending on your problem nature, you can choose any one of them. Then comes learning rule. So using this learning rule, you could able to adjust the weights of the weights associated with the neurons using the training data. That is back propagation. You can use the back propagation and gradient descent technique. These are the learning rules. You can apply this learning rule to adjust the weight and biases, because these two are in your hand, which you can adjust to find to reach at your desired uh, solution. Then comes types of ANN. So types of ANN, first feed forward neural network. It's very simple. Data flows in one direction only. So this is that is why we call it as feed forward neural networks. No feedback loops you will find in this neural network. Then convolutional neural networks. It is used for image or video recognition. It is specialized, I mean, developed for images, and recognizes the patterns like edges and textures of the image. And the next is recurrent neural networks. Recurrent neural networks, it is designed for sequences like time series data, text data, or speech data, and it uses feedback loops. That is why the name is recurrent neural network. Then radial basis function networks, it uses distance measures technique, effective in classification problem. Then modular neural network, multiple small networks combined together, and they work unitedly. Then deep neural network, multiple hidden layers for complex problems can be used, so that they can analyze the problem in depth and could able to find the best solution for the problem. Then comes fuzzy logic. So what is fuzzy logic? It is a traditional, as you know, traditional computing is binary. Like things are either 1 or 0, true or false. But real life is, very real. You can find very rarely real life problems deals with crisp values. For example, you can't say temperature is always hot or cold, or at 29 degrees centigrade, you can't say it is hot. So maybe for one person, it might be hot, but for the other person, it may not. So fuzzy logic helps us or allows this reasoning power with the degrees of truth between 0 and 1. So fuzzy logic actually deals with the gray areas of decision making, just like the way human beings do. Then the key concept of fuzzy logic is fuzzy set. We use fuzzy sets. Unlike the classical sets, uh, fuzzy sets assign each element a membership degree. Okay. So, and the membership degree varies from 0 to 1. When it is 0, that means that element is not a member. But when it is the membership degree is 1, it is fully a member, fully into the set. The values, in between 0 and 1, suppose 0.5 or 0.2, 0.8. So those values show partial membership of the element. And for example, if we take, example of tall people, a person having 170 cm height might have a membership of 0.5, while the person who is 190 centimeter may have the membership value 0.9. So the membership function can be defined. The graphs can be used to define this membership function. So the graphs that define how each input maps to the membership values. And the shape of the graph may be a triangular shape, trapezoidal shape, or Gaussian. Then again, fuzzy logic allows us to use linguistic variables, human like terms to describe the values like low, medium, high speed, etc. And fuzzy rules are also defined using if then, which are used for reasoning purpose. For example, if I say if temperature is high and humidity is medium, then fan speed is fast. Then another concept we use here is fuzzy defuzzification and or fuzzy inference system. So fuzzy inference system uses rules and membership function to make the decision. And after this, I must tell you another concept, defuzzification. It converts the fuzzy output back into the crisp value so that it can be used by the machine control. Then types of fuzzy system, Mamdani fuzzy system. It's a classic model. It uses fuzzy rules plus fuzzy sets, and it is good for decision making and control systems. Examples like washing machine adjust, cycle adjustment, washing cycle adjustment based on the dirtness can use this Mamdani fuzzy system. And Sugeno Takagi Sugeno system. Here the outputs are mathematical functions, linear or constant, not fuzzy sets. So easier for optimization and adaptive system. It can be used in adaptive cruise control in cars. What are the advantages of fuzzy logic? The advantages of fuzzy logic, there are many. The first one is handles uncertainty. It works well when information is incomplete, vague, or noisy, and it does human-like reasoning. Rules can be expressed in natural language, and also it is robust and flexible. Even if you find inputs change slightly, outputs are smooth and very easy to implement. It is great for real world systems without complex modeling. and widely applicable, used in consumer electronics and robotics, automotive systems, and decision making tools. So these are the advantages of 4G system. And then let me take you to another evolution, another computational intelligence tool, that is evolutionary computation. So evolutionary computation, as the name says, it is a branch of computational intelligence. It draws inspiration from the principles of natural evolution and genetics. Just like nature evolves species to survive in the changing environments, evolutionary computation also evolves solutions to complex problems over time. It is widely used when search space is very huge, non-linear, uncertain, or poorly understood, where traditional methods may fail or may not work. Then the key concept of evolutionary computations are, first one is population based search. Instead of working with a single solution, evolutionary computation always works with a population of possible solutions, and this increases the diversity and reduces the chance of getting stuck in local optima. Then comes fitness function. It is a measure of how good a solution is, how good a candidate solution is. It guides the search process, and the fittest solutions are more likely to survive and reproduce further. Then, genetic operators. Under genetic operators, selection will come. Selection chooses the best solutions for reproduction. Then crossover is another genetic operator or recombination. It combines parts of two or more solutions to create new solution. Then mutation is another operator. Mutation, it just it makes a random small change in the solution to maintain diversity. Then comes survival of the fittest. Iteratively, better solutions survive while weaker ones are eliminated. Then convergence over multiple generations, the population gradually improves and converges towards an optimal or near optimal solutions. So, what are the advantages of using evolutionary computation, or evolutionary computation? It handles complex problems. It works well for nonlinear, multimodal, and high dimensional problems. And it doesn't need, I mean, mm, gradient information. So, no need to get gradient or derivative information. So, unlike traditional optimization, uh, evolutionary computation does not require derivatives. That is one of the most important advantage of using this evolutionary computation. And the third one is flexibility. It can be applied to optimization problem, learning, designing, scheduling, robotics, etc. And global search ability. It can escape local optima better than many classical methods. And also, it has the advantage of adaptability, naturally suited for dynamic and changing environments. Then major evolutionary computation techniques are genetic algorithm. This is the most popular evolutionary computing technique. It uses chromosomes like structures. Those chromosomes are defined maybe using binary strings or real numbers, and it applies selection, crossover, and mutation to evolve solutions. And applications, already I have told you, it can be applied for scheduling problem, routing, and also optimization, design optimization problem. Then the second one is genetic programming. It extends genetic algorithm to evolve complete programs or sequence instead of fixed length strings. And here the solutions are represented as trees. And evolution strategies, it focuses more on self adaptation of strategy parameters like mutation rates, and typically it uses real valued vectors. Then next is evolutionary, yes, differential evolution. Differential evolution, it is a population based technique particularly effective for continuous optimization problems. It uses vector differences for mutation and recombination, and it is known for simplicity and efficiency. Then let me take you to evolutionary computation. One of the most popular technique of evolutionary computation is genetic algorithm. So this is a flow chart where I have just mentioned what are the steps generally we follow here. So in this in this genetic algorithm flowchart, the first step is initialize population. So here, as let me tell you before I come to the first step, genetic algorithm, as I have told you, but again let me repeat, genetic algorithm is a search and optimization technique, and it is inspired by the process of natural selection and genetics. Okay, then you come to the first step. First step is initialize the population. It starts with randomly generated set of possible solutions, and those set of possible solution is called population. So, first you randomly create the possible solutions or the population. Then each of the solution of the population is called a chromosome, or you can call them as individual, which is represented in a coded form, often as a string of bits, or numbers, or symbols. Then after this initialization step, we come to the next step, which is evaluate fitness or evaluation step. So fitness evaluation step says each of the individual or the chromosome in the population is evaluated using a fitness function. So here you have to define a fitness function, and that fitness function will evaluate the fitness of the individuals of the population. The fitness function measures how good the solution is for the given problem. Then, like for example, in a scheduling problem, uh, uh, it could inform how well a timetable avoids classes. It's in a scheduling problem. But if we apply it in optimization problem, then we could find how close a design is to the ideal solution. Okay, so the fitness function helps us to, find the ideals. It can say how close we are to a ideal solution, or similarly for a scheduling problem, whether we are avoiding classes in the timetable or not. It could be found through this fitness function. Then third step is satisfy constraints. So there are many constraints, as you know. So after finding the fitness value, the algorithm checks if any solution satisfies the problem's constraints or stopping criteria or not. So the criteria may be reaching the desired accuracy, or completing a number of generation, or finding satisfactory solution. So if the check has satisfying criteria is yes, now stop and output the best. You see, if it is yes, then you output the results. You just stop the computation here. If it is no, then select, continue the evolution, continue evolving the solutions, more efficient solution. So randomly vary the individuals. Again, you find for every individual the fitness value, and then again you check whether it is satisfying the constraint or not. Then step 4 is select survivors. If no, you are coming to the step 4, select survivors. So from the current population, select the fittest individuals, those with higher fitness values. So this step mimics the survival of the fittest. And then selection methods. The selection methods include, what are the selection method we apply here to select the survivors? You can select Rowlett wheel selection, tournament selection, or rank based selection. Then comes step 5. Step 5 is randomly vary individuals. What is that? Here you are creating new individuals through genetic operators. So now we can use the genetic operators like crossover, mutation, etc. So the crossover is nothing but the recombination technique. It combines parts of two parent solutions to create a new offspring. And similarly, we can use a mutation operator, which randomly alters part of a solution to maintain the diversity. So this ensures the search explores new areas of the solution space. So now you come to the loop back, this one. The new population is again evaluated and the cycle repeats from step 2 to step 5. Over the generations, the population evolves with better solutions emerging. And then the final step is the output results. Once the stopping condition is satisfied, the algorithm outputs the best solution found. So GA algorithm starts with random guesses, evaluates those guesses, and through repeated selection, crossover, and mutation, it evolves increasingly better solutions until it finds an optimal or near optimal solution. Okay, let me have some water. Then after this genetic algorithm, let me, okay, what was this? Evolutionary computation, genetic algorithm we discussed. Then applications of evolutionary computations. So you can find the application of evolutionary computation in many areas, like optimization problem, like engineering design, scheduling, resource allocation. Similarly, learning problems. In machine learning problems, you can apply for feature selection, hyperparameter tuning. Also, it can be applied to robotics for finding path planning, control system optimization, and bioinformatics problems can also be solved through this. And game development by strategy of evolution, and also by using AI behaviors and strategy evolution, we can use, or we can develop this, we can apply this for game development. And then, okay, so let me tell you a little bit about machine learning, how the evolutionary computation can be used for machine learning problems. So for machine learning problems, generally we apply for feature selection. So this evolutionary computation helps automatically choose the most important features from the huge data set. So thereby it improves the accuracy and reduce the model complexity. And similarly, hyperparameter tuning, what is it? AC can evolve the best settings for algorithms like the parameters of the algorithm like learning rate, network size, or regularization parameter in neural network or SPM. So once you tune the parameters, hyperparameters, then definitely it will help you to find the best possible solution. Similarly, in robotics, path planning, EC actually helps robots find optimal routes while avoiding the obstacles. You can find the application of this EC in autonomous car, drones, etc. Then come to bioinformatics. Gene sequence analysis. EC can analyze DNA or protein sequences for finding similarities, mutations, and evolutionary relationship exist. Similarly, it can also be applied to drug discovery. It helps explore huge chemical spaces to propose potential drug candidates. And then the last one is game development, strategy evolution. So EC is used to evolve intelligent strategies in games, and also AI behaviors. The like non-player characters can adapt and evolve their actions to make games more challenging and lifelike. So these are the different applications of evolutionary computation. Then next is swarm intelligence. So swarm intelligence refers to a collective problem solving behavior, and it is inspired by social organisms such as ants, birds, bees, and fish. It has real world impact across engineering, healthcare, AI, robotics, and even entertainment area. And the strength of uh, this, I mean, mm, the strength lies, the strength of this evolutionary computation lies in solving problems which are very large, uncertain, or dynamic for conventional algorithms. And swarm intelligence, as I said, it is inspired by the collective behavior of social organisms like ants, bees, birds, fish, and even human crowds. So the central idea here is simple agents following local rules. So all the agents they will follow some local rules, and collectively they form they I mean a intelligent uh, behavior will emerge out from the collective uh, from the collective behavior. I mean, the um, uh, I mean the all the agents here. Each of the swarm we call them as agent. So all the agents they will follow a local rule. Okay, and then combinedly or collectively they form the global rule, which is the intelligent. We can call it as an intelligent behavior, which will emerge out from the swarm, I mean, from the flock of birds or the flock of school of fish. And here, without having any central controller or a coordinator, a central coordinator, the complex problem can be solved using the collective behavior of the agents. So, just like an ant colony finds the shortest path to food, or a flock of birds flies in perfect formation, swarm intelligent algorithms mimic this self organization behavior to solve the complex problems. So the key characteristics of swarm intelligence is one, the first one is decentralization. No single agent is in the charge or act. Central having central control. Agents act independently. Intelligence comes from interactions among many individuals. Then second one is self-organization. Patterns emerge naturally. That is, birds flocking or fish schooling That is the pattern that will emerge naturally without any external control. Then third one is adaptability or flexibility. So swarms adjust quickly to changes in the environment. Like you can find ants finding new paths if one path is blocked. Immediately they can find the new path, the other second path. And fourth one is robustness or fault tolerant. Even if some agents fail, the system keeps functioning, just like a bee colony survives, even if some of the bees die. So the emergent behavior the behavior which is emerged from this particular swarm intelligence is complex, and the global behavior arises from simple local rule. Then the major techniques are particle swarm optimization inspired by bird flocking or fish schooling. And here the agents or the particles move in space guided by personal based and global based. Second one is ant colony optimization, which is inspired by how ants lay pheromone trails to find the shortest path to food. So problems like routing problems, scheduling, and optimization problem, you can use this ant colony optimization. And artificial bee colony. So it mimics honeybee foraging behavior, and it is effective in optimization and clustering. Then other algorithms like Firefly algorithm, BAT algorithm, cuckoo search algorithm. BAT or cuckoo search algorithm, it mimics echolocation, or the bats are brood parasitism for cuckoos, useful in optimization, research allocation, and search problems. Then the major applications of swarm intelligence is optimization problem, robotics, data mining and machine learning, healthcare and bioinformatics problems, economics and business. Also, you can find the application in game development and animation. Then let me come to the applications, which is very, very important. Applications of computational intelligence. First, I have taken healthcare and bioinformatics. So, uh, healthcare and bioinformatics, as you know, computational intelligence is transforming healthcare by using machines to analyze complex biological and medical data more effectively than humans can do. So, for medical diagnosis and disease prediction, actually, what it means, the computational intelligence models like neural network and fuzzy system and evolutionary computation can analyze patient records, lab reports, and symptoms to assist doctors. So, for example, predicting cancer risk from biopsy images or estimating the likelihood of diabetes and heart diseases from health records can be done very effectively using this computational intelligence technique. Then why it matters? Because always we want early detection of the disease so that lives can be saved and also the cost can be reduced. So here in this, problem like medical diagnosis and disease prediction, CI does a, acts very brilliantly, very effectively, and also helps the doctor or the practitioners to detect or to find the disease quite early. Then second is drug discovery and genetic data analysis. So drug discovery is like finding a needle in a haystack. It's very complex. Evolutionary computation and swarm intelligence are used to explore this vast chemical spaces and identify the potential drug compounds. And genetics, when we apply CI, it helps analyze DNA sequences to detect the mutations where it happened and understand the genetic disorders. And if I give the example, you can find the application of CI, finding candidate drugs for cancer treatment or analyzing genetic markers for personalized medicine. So in this area, this CI can work very effectively or very the potential application you can find in this area. So third one is image analysis in radiology and pathology. Radiology scans like X-ray, MRI, CT scans, and pathology slides. The data is huge, and it has huge image data set. So the computational intelligence powered image analysis identifies the patterns and abnormalities in this scan reports or in these images. So, detecting tumors in MRI scans, identifying lung infections from X rays, or analyzing blood samples for anomalies. So, all of this can be very effectively carried out using the CI techniques. I mean, image analysis in radiology and pathology, where we can use this, apply the CI technique. Then why it matters? Because it reduces human error and provides faster, more accurate diagnosis. So that is why we use CI in these applications. Then next application area is finance and business. The financial world thrives on predictions and risk management. And CI offers powerful tools for uh, both the area, finance and business. So first, let me take stock market forecasting. Uh, stock market forecasting, CI algorithms can be used to analyze massive amounts of historical and real-time market data, so that it can uncover the trends lies in those data and could able to predict the future stock movements. So, for example, using neural networks to forecast stock prices or applying genetic algorithms to optimize the trading strategies. So, here we can use both neural network for forecasting and genetic algorithm to optimize the trading strategies. Then, why it matters, why it is necessary? Even a small improvement, as you know, in prediction accuracy can result in huge financial gains. So, that is the only reason why uh, we apply, I mean, CI in this type of problem. Then fraud detection in banking. Fraudulent transactions often show hidden patterns in timing, amount, or behavior. So CI systems detect anomalies in real time. Like it can spot unusual credit card activity, detecting money laundering schemes. So, to protect the customers and saves the what billions of rupees in the bank, and also through this trust can be built up between the customer and the bank. So this is to gain all of this, like to provide protection to the customers and building trust also saves money. The CIE techniques can be used for this particular type of problem. So that we can get a lot of benefit. Then comes credit scoring and risk assessment. So, what it means, when banks evaluate loan applications, they use computational intelligence models to assess whether a person is likely to repay or not. So, neural networks trained on the repayment history and income data of the customer to find out the risk score. so that it provides fairer and more accurate credit scoring compared to the traditional model. So these are the different advantages of using CI. Then taking to another application, robotics and autonomous systems. It can be used for path planning and navigation. So I'm not explaining more about this. I will take you to another, yes. Uh, yeah, for you, control and automation, maybe this is important, and autonomous system. Okay, let me explain about robotics and autonomous system. So what happens in robotics and autonomous system? Uh, we can find like the robots and autonomous vehicles need to decide how to move from one point to another safely and efficiently while avoiding the obstacles. So path planning and navigation can be effectively done through this technique. And the role of CI here is the techniques like evolutionary algorithm, fuzzy logic, and swarm intelligence. Just a minute. Evolutionary algorithms, fuzzy logic, and swarm intelligence can be used to optimize the path in dynamic environments. So the examples of this this autonomous systems are autonomous car driving, autonomous car navigating, and autonomous car navigating and navigating city traffic. Then drones delivering packages through crowded airspace. So these are the different. Then second one is human robot interaction. So what is it? It ensures robots can work with humans in a safe, intuitive, and intelligent way. So the role of CI here is machine learning models interpret the speech, gestures, and emotions for smooth collaboration or smoother collaboration. So the examples of this are healthcare robots, which can assist patients, collaborative robots, or you can call them as cobots in factories working alongside the humans. Then third one is swarm robotics for search and rescue. So what is it? Groups of swarm robots cooperate like bees or ants. You can use a group of simple robots which can solve complex problems. Then the role of CI is swarm intelligence helps coordinate distributed robots to explore, map, and find survivors in hazardous environments. So the example is swarm of drones locating survivors after earthquake. You can use there. Underwater robots can detect oil leaks. So these are the different applications or examples. Sorry. And then the next is industrial control and automation. So under this process optimization in manufacturing. So what is it? It improves the efficiency, quality, and speed of industrial processes. And the role of CI here is evolutionary computation and neural networks optimize the production parameters like temperature and pressure, speed. So it can reduce the defects in for example, it can be used to reduce defects in semiconductor manufacturing. Also, it can be used to optimize the assembly line scheduling. Then predictive maintenance. Predictive maintenance is very, very useful. Very important. Instead of waiting for machines to break down, here we can use sensors and the computational intelligence technique to predict the failures in advance. So here, what exactly the CI does, the techniques like neural networks and fuzzy logic analyze the sensor data and forecast the breakdown. So, for example, monitoring vibration in turbines Also, you can predict the failure of railway engines. So, using this type of, because of the application of CI in this type of, in this area or in this domain of application, mm, we not only saves money, also avoids downtime and improves the safety. Then, smart energy systems, grid management and load forecasting. It comes. These problems comes from your area. What does it mean? Power grids must balance electricity supply and demand in real time. So here, what CI can do, CI algorithms forecast energy demand and optimize the power distribution and integrate the renewable energy sources so that forecasting peak electricity usage to prevent blackouts, it can be done. Also, it can optimize the charging schedules for electric vehicles. So these are the different applications. Take you to applications of CI in natural language processing. I'm not going deep into this because my time is already going to over. So, as you know, natural language processing can be used in speech recognition and translation, sentiment analysis, chatbots, which is very popular nowadays. And every time, for banking and for any kind of your online marketing, you are using chatbots or virtual assistants like Siri and Alexa. We are using for our for daily day-to-day life activities and transportation and logistics. Through this, traffic flow optimization can be made. Airlines logistic planning can be made. Self-driving cars, we can use apply this technique. Then environmental and agricultural system. So application of CI also you can find in this area, like weather forecasting and climate modeling. All of you, every day you must have getting information about the weather condition, forecasting for 7 days or for the current, even hour to hour basis, you can get the forecasting information. Also, it can be used in precision farming and crop yield prediction, disaster management, and resource allocation. So these are the different applications of computational intelligence. As you know, computational intelligence nowadays in all our day-to-day real life problems, we are using the CI, computational intelligence, to find a dependable solution or the solution which is good enough to rely. So this is all about my topic, my lecture. So uh, I would like to get some question from the participants, if there is any. Hello.
Yes, ma'am.
Yeah. Do you have any question?
No, ma'am.
No question from the participants. Is it a repetition of the first lecture?
No, madam, not at all.
Okay,
It is different completely.
okay.
So, any participants, if you want to know anything, because ma'am has covered completely optimization techniques. Actually, these are using now in different research area, and which will be helpful for you to if you are working in any optimization technique in different field. So this session, I think it will be helpful for all of us. So anyone have any doubt, please ask.
Yeah, I can answer.
All the participants are here. Please ask if you have any doubt.
Any questions, please? How many participants are live now?
Ma'am, now it is 61.
Oh, good number. But 1.5 hours is too much. Really,
But
I'm
it
losing
is
my patience.
It is how it got over, we actually didn't know.
Yeah. But it's really painful.
But
Okay.
thank you, ma'am. We got to know many things from this session. Thank you so much.
Okay. I have given my email ID. If anybody is having any question or wants to know something more about any of the topic,
Yeah.
please send an email to my inbox. So I'll be happy to answer your questions.
Yeah. Sure, ma'am. Sure.
Thank you. Thank you, ma'am.
Okay. Thank
Okay,
you so much, Rupali.
Good night.
Okay, thank you so much, ma'am, for your insightful and enriching session on evolutionary computing. Your deep expertise and vast experience have given us a clear perspective on the application of computational intelligence in the today's world. On the behalf of organizers and all the participants, I extend my heartfelt gratitude to you for sharing your valuable time and valuable knowledge with us. We are sure that the ideas you presented today will inspire new thoughts, research direction, and application in our professional journey. Once again, thank you, ma'am, for being with us today and making this session truly remarkable.
Thank you.
Thank you, ma'am.
Thank you
Thank you, ma'am.
all, and especially Rupali and Prasantini.
Thank you,
I'm
ma'am.
okay. Thank you. Good night.
Okay, good
Good
night,
night,
ma'am.
Good
Then
night,
now,
ma'am.
feedback session. Dear participant, I now request you to kindly provide your valuable feedback for this session. Your feedback helps us to improve and also ensure that AICT requirements are fulfilled. So the feedback link has already shared, I think, in the chat box. We request everyone to complete it within next few minutes so that we can close the program.
Okay, I'm just leaving.
Yes, thank you, ma'am. Thank you once again, ma'am.
Thank you. Thank you.
Yes, ma'am.
All the participants are requested, please switch on your video so that we can take the final attendance. Okay, and one request, all of you are requested to join in your personal mail ID because some of the name are coming like HOD MTech, HOD MCA, so it will be unable for us to give the attendance. So kindly join the meeting in your personal email ID, which will be helpful for us and for you also. Otherwise, we could not put the attendance in the Hotel FDP site. So it is a humble request, and all of you are also requested to give the feedback of individual session. That will be helpful for us also. And the link will be shared in the WhatsApp group and also in this meeting ID. So kindly fill up the feedback form and submit it in the same day, and we will join tomorrow for at 6 p.m. We have 2 session and 2 resource persons with us. Hope this session, these 2 sessions are helpful for you for different research area, and whatever the your area, it will be helpful. So thank you so much, and hope you will enjoy this 1 week program. Thank you so much. So kindly provide your feedback in the link. It is a humble request. So
Thank you, ma'am.
any doubt, if you have faced any problem, any doubt regarding this session? Dear
Okay,
participants, is there any problem in today in any session?
okay, with this,
No, ma'am. No.
Thank you so much.
with this, we come to close of
Ma'am,
our
please provide the feedback link in WhatsApp group.
Okay, yes, sir.
Actually,
Yes.
first session feedback form already shared, and the second will be shared soon. So
Already
kindly
shared, ma'am.
provide it,
Already
and
shared.
and don't worry, the PPT will be shared in the WhatsApp group also, which will be helpful for you. Anything else?
No. With this, we come to close of day 1 of our faculty development program on computational intelligence and application in power engineering. On the behalf of organizing committee, I sincerely extend my heartfelt gratitude to all the participant. A big thank to you also participant for active involvement and enthusiastic participation, which has truly made today's session meaningful and interactive. We will reassemble tomorrow at 6 p.m. for day 2, where we have more exciting and insightful session awaiting you. Until then, we wish you a pleasant evening. Thank you. Stay safe and see you tomorrow again.
Thank you. Thank you.
Thank you, ma'am.
Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you all.